Greetings and welcome, friends. Mr. Waddy here. We are talking about angles. I was almost at areas, but no. These are angles. They start with the letter A. That can be tricky sometimes. But page 236 from chapter 5.1, Big Ideas Geometry. Me and my friends IRL are just going to be going over some homework problems and punching holes in some paper. But we would just like to invite you into this moment. We're just going to have this wonderful dialogue conversation, me and my friends IRL. And they're going to ask questions. It's going to be great. Hopefully my explanations will suffice. All right, that's enough with the hole puncher. Try the other one. The other one might be better. Question 8. Let's plot some points. Here we go. A is 3, 3. Bada bing. Also, if you're a fan of these coordinate planes, which who hasn't been, I've created a sheet of coordinate planes on the just beneath the screen right there that you can grab a bunch of those. Yeah, you could take those home if you want. Or not even for homework, maybe just for fun, and you're just like, I just want to go home and plot some points. And yeah, so you could do that at home. Yeah. Let's see, so 6, 9, ladies and gentlemen. Let's see, did I land on the right one here? 1, 2, 4, 6, yeah. I could share that in the description below, maybe. That's not a bad idea. All right, Malik, you with me? Lauren, see, this is the chit chat. Here we go. Don't worry, you still making noise, Lauren. Don't you worry. Here's C. 6, -3. I'm the only one in the world. The only one. Let's see. So there's our triangle, and then they asked us to classify it. I don't know. What do you guys think about this one? It's isosceles. You're thinking AB and AC are congruent? Yeah? How would you have determined that? If I did the distance formula between A and B and A and C, you could verify those are the same. Also notice the way that these move from A to B. If I go up 2, 4, 6 over 3, and this is down 2, 4, 6 over 3, yeah, those distances are going to be the same. So it's isosceles, I would agree. Isosceles. And you guys are claiming obtuseness. I would agree. Yeah, I would agree. Obtuse. There you go. All right, let's keep going. Pick up the pace. Find the measure of angle 1, then classify. Let's see, what was that? The corollary to the trisum theorem? I know that these two angles will be complementary. Excellent, excellent. So let's see, measure angle 1 plus 38 is going to equal the 90. Subtract the 38 from both sides. And let's see, measure of angle 1 is equal to 52. Someone is saying 52. Okay, so there's the measure of angle 1, friends. Classify it. It looks like a right triangle. Now, do you guys have any claims regarding isoscelesness? What do you guys think? I'm going to say I happen to know for sure it's not isosceles. Oh, true story, true story. Thank you, good call. In case you're wondering, it is also scalene. Yeah, it's guaranteed scalene. But you won't know that for sure, Malik, who's going to be quiet and listen, maybe ask some valid questions. You won't know that for sure until later on when we know about some more theorems and converses. It's going to be great. Let's see, find the measure of the exterior angle. All right, yeah, I could do that. You guys might recall the exterior angles theorem, which says that the exterior angle is equal to the sum of the two remote interior angles. Right? Yeah, we did that. So let's watch this. I'm going to do some two-stepping. Subtract 2x from both sides. Also, I'll combine some like terms over here. I hope so. I'll have x plus 6 equals 18 plus 20 is 28 plus 4 is 42. Subtract 6 from both sides. Am I right so far? I have no idea. And I'll have x equals 36, 7. Ay. And then, but they asked me for the measure of the exterior angle. So that means 3 times 36 plus 6 is what we got to do, right, Lauren? So 3 times 30 is 90, plus 3 times 6 is 18. So that's 108. I don't know why I've got that extra parenthesis there, just for fun. Sometimes, yeah. Let's see, 108 plus 6 is 114. You guys agree? All right, cool. Let's keep rolling. Oh man, these problems keep coming. I'm just going to do the setup for this one. The measure of one acute angle is 5 times the measure of the other acute angle in a right triangle. So let's see, if this is something and then this one is 5 times as much, don't you worry, not drawing the scale. I'll say x plus 5x is equal to 90. Actually, guys, we're already here. Let's just solve this. Let's see, guys. I need someone to help me. 3 goes into both of those. What's that? 30 over 2. Looks like 15. No. All right, and then the problem you've all been waiting for, ladies and gentlemen. Yeah, boy. Here we go. You could just actually go back and watch this YouTube video, play it at half speed. You're welcome. Prove the exterior angle theorem 5.2. So let's see, triangle abaca is given, and exterior angle. Let's do this, friends. So statement and reason. Let's see, we'll set this up. Statement and reason. Actually, there we go. All right, so we would have our given information. I don't know, triangle ABC exists, and angle BCD, it exists as such. Right? Those are given. Here, let's stop making unnecessary noise pollution there, Malik. Thank you. So let's see. Let's do some proving. We got our given. Triangle sum theorem we know. Okay, so I would say for triangle sum theorem, I would say the measure of angle A, that the sum of the interior angles, it's an exterior angle is all they're saying. Because otherwise, like, you know, like when we did geometer sketchpad and you guys just like made a fake exterior angle, one of those things. So let's see, measure of angle A plus the measure of angle B plus the measure of which angle? BCA is equal to 180 degrees by the trisum theorem. Try some potato chips. No, but I'm hoping they might, like, one day just be like, hey, thanks for that shout out, Mr. Waddy. Just try some brand. Okay. All right, how about this? This angle right here and this angle right here, what types of angles are those when their powers combine? Angle BCA and angle BCD are a linear pair. No, because there's multiple angles that happen at angle C. So I don't know. I don't know, right, Lauren? We just don't know. We don't know. So that's why I've got to be explicit with a name, so that way we'll know which angle C we're referring to. So let's see. So this is def of LP. Linear pair. All right, so this angle right here, this angle right here, and this angle right here are a linear pair. The fact that they're a linear pair tells me what now? That the measure of angle BCA plus the measure of angle BCD is what? This is what you got. Some of you guys said as the get-go. What would you say? But they add to what number? 180 degrees by the linear pair postulate. LPP, yeah, you know me. Linear pairs add to 180. All right, there we go. All right, here we go now, friends. They're claiming transitivity on this. Oh, yeah. See it now. I see it. You guys see it? All right, watch this. Here we go. If this is equal to 180 and 180 is equal to that, the measure, here Isaiah please, the measure of angle A plus the measure of angle B plus the measure of angle BCA is equal to this guy, transitiveness. Man, that took up all the space. Transitive property. Okay. Here, I'll draw this little box around this right there. That. All right, so Malik, what do you think my last statement is going to be? I think we've proven it. Measure of A plus the measure of angle B is going to equal the measure of angle BCD. How did I get from this statement to this statement? Oh, almost. Subtraction, you mean. Subtraction property of equality. All right. If I was to write the step, subtract the measure of angle BCA from both sides, then it would have worked out just grand. Just grand. Write that, Aiden, you got that? Isaiah, question, comment, observation? Oh, yeah, you're right. Like I abbreviated some. That's funny. Yeah. There we go. Problem solved. Also, thanks for watching, internet friends. Have a good day proving your triangles. Bye.